So we've been looking at teams and why they form leagues. And what we want to do is we want to kind of look at this idea of competitive balance now. So let's extend our analysis and let's look at, we have a simple league of two teams. So because we saw earlier that profits can be different for these different teams, especially small versus large, right? So let's look at our quantity of winning here. Win is equal to 1. Win is equal to 0. All right? And let's look at the marginal revenue here for two different teams. So we've got a small team, got a large team, right? We're looking at their marginal revenue and we're looking at their level of winning. Going all the way from 0, obviously, to 1. Right? And one of the things that you'll notice on here, of course, is that the marginal revenue for these two guys is not exactly equal. So that for any given level of winning, whatever it is that the number is, it can be any number that you want it to be. Just call it, say, W, let's not even call it W star. Let's just call it W2. Some level of winning W2. Our small team is going to have this level. Large team is going to have this level, right? Our large team has a larger amount of revenue for any given level of winning than our small team. So what we want to do is we want to extend this analysis to this idea of competitive balance. And let's take this guy, and we're going to take one of these guys, and we're just going to flip them like this, all right? So what we get, something that kind of looks like this, right? So I'm going to put, which one do I want to put where? I'm going to put small over here. So at this point right here, we had to remember we have a two-team league. If the small team is winning 100% of the games, the large team has to be winning 0. If over there, the small team is winning 0% of the games, the large team has to be winning that. So, got this guy over here. And we've got our marginal revenue for our large team. Doing something like this. Our small team. Something like this. Let's make this more. That looks like halfway. Now, a couple other things that are interesting. You know that in economics, every time lines cross, something's happening. So let's just take some point. It can be any point that we want it to be. I'm going to call this point, say, W2. Here's W2. And we see here at W2, Here's the marginal revenue for our small team. Here's the marginal revenue for our large team. Now remember, let's think about what this guy says, right? At some point in time here, about the halfway point through this guy, somewhere maybe in, say, here-ish, about 500. Right? So we have our small team here winning some amount, W2, whatever that amount W2 is, roughly more than 500. Our large team winning less than 500. And if you look at this, for every single additional win that the small team gets, their marginal revenue is going to be this guy, this MRS2. Our large team is going to be MRL2. Now, think about this. Who are wins more valuable to? Large team, right? Their marginal revenue is this guy right here for winning another game. There's the small team's marginal revenue from winning another game. And remember what we said, what it takes to win, right? What do we have to do? We have to have the stars, right? And so we had this idea of the number of stars. Right? And that would give us some kind of function like this in terms of our winning. And so then in essence what we said is that when you combine that with the number of costs, right, because these players are going to cost more, you can actually get these profit functions that kind of look like this, right? So that here's the profit function for, say, maybe the small team, right? And here is the profit function for, say, the large team. So maybe the profit for the large, they're winning here is WLs. What they need to do is with small team come here, say WS, right? That was their optimal amount of winning. That was their optimal amount of winning, right? The idea being that in order for the Tampa Bay Devil Rays to consistently beat the Yankees in the World Series, or I guess in the same division, the pennant, they've got to have a whole lot more stars than the Yankees. So they've got the same cost as the Yankees, but they're in a much smaller market. They're not going to be able to get enough revenue from that, right? So even though they might have the same cost as the Yankees, the revenue will not be enough to compensate for those additional costs. It makes sense for them to have fewer stars. It makes sense for them to have fewer winners. Same thing here, right? Every additional win for the team, for the small team, they're in a small market. The additional wins aren't as valuable, right? And so what we see here is you can see an equilibrium or a disequilibrium where winning is more valuable to the large team than it is to the small team. And in fact, they would be willing to pay up to this much in terms of for more talent in order to get another win, right? If they could pay anything less than this, if they could pay $2 million and have $4 million worth of marginal revenue, it makes sense to do it. It doesn't make sense to pay more than that. Same thing here for the small team, right? Their marginal revenue for the next win, maybe it's $50,000. What do they have to do to win the next game, right? Well, they're going to have player X, and player X averaged out over all of these games means that we're going to have to pay him $80,000, right? And well, it doesn't make sense to do that, right? And so we don't hire that guy. We have this other one here. Let's go back. Let's make sure we understand this point because it's an important point. Who did we say was in the very bottom this year? Do you guys remember? Was it the Rockies?
Padres. Giants.
So here's our player here, 4,500 just for this year. So we've got it's going to cost us an average of, let's just call it 28,000. It's going to cost us an average of $28,000 for this guy, right, per game. But if every single game isn't worth that, we're only going to get $15,000 in revenue. It doesn't make sense to hire the guy. See what I'm saying? As opposed to this guy, 535,600. He's only costing us $3,000 a game. So hiring this guy, and each game's going to get, I'm just making up a number. Right? We've got the whole roster set except for this last person. We have to choose. Do we hire Manuel or do we hire Will? Will's costing us $28,000 a game. Manuel's costing us $3,000 a game. If the next win is going to get us $4,000 in revenue, it doesn't make sense to hire the guy that's $28,000. We hire the guy that's $3,000. You see what I'm saying? There's in essence a problem. So we have these different sets of winning, right? We have these different sets of winning for our teams. That mean for our different team sizes, it can make sense for us to win different amounts. And the exact opposite happens over here. Right? So over here, I'll call this level of winning, say W3 or W1. Here's the marginal revenue for our large teams win. Here's the marginal revenue for our small teams win. What's happening here?
This whole thing's winning more. Having more margin revenue with the large teams losing margin revenue.
Well, they're not losing margin revenue, they're marginal revenue. The next win is worth how much to the large team? This guy, it's worth that much. Right? And the small team's next win is worth that much. The small team is willing to pay up to this to get the next win. The large team is willing to pay up to that to get the next win. It's more valuable to the small team to have another win than it is to the large team. And in fact, the small team would be willing to pay. If you think of this as how much am I going to have to pay, don't think of them as a roster. Think of them as here's a pool of players. And that's their salaries, right? These two teams. And I'm going to draw and I'm going to get those players every single game, right? It's just like back in middle school basketball on recess, right? Everyone's standing up there and you just sit there, I choose this guy, I choose this guy, I choose that guy. It's basically that, right? And so you're saying, hey, we're this guy here, I'm willing to pay up to this guy for the next win. Right? here at this point, we see the large team is actually winning too much. Our small team isn't winning enough. And since wins are more valuable to our small team than they are to our large team, our small team is willing to pay more for them. They will buy more talent. We see what has happening here is we've got some W star, some optimal amount of winning. And we see at this point, the next win for the small team and the next win for the large team are exactly equal. The next win is equally valuable to both. We're willing to pay up to MRS or MRL star for the next win. Now, interestingly enough, W star, number-wise, is equal to what? Where is he closer to? Which axis? Is he 500?
No.
No. Where's he at? Yeah. So we'll just call it 600. 600 for which team?
Large.
Large team. Which means what for the small team?
Less.
400, right? When you're looking at this, I mean, in our two-team model, it's pretty simple, right? In a multiple team league, you know that the sum of the winning percents must equal half the number of teams. So that you have, say, 1 over n, summation I equals 1 to n, I has to be equal to 500, right? Where n here is our number of teams. Wi is our winning percent. Or you can multiply this guy in. Same thing. And this is true for every league. All of those ones have to add up to 0.5. They have to. So at this point right here, W star, what we see is that it no longer makes sense for the owners to try to bid away talent from the other team and vice versa, right? Before at W2, the large team wants to bid away talent from the small team. Before at W1, the small team wants to bid away talent from the large team. And at W star, nobody wants to do anything. Everyone wants to keep the talent that they have. So we see that there's several different things that are happening here at W star. Right, we've got marginal revenue being equal among the teams. Remember, marginal revenue is not the same thing as total revenue. So we're not saying that revenue has to be equal between the teams. We're saying the marginal revenue for the next win has to be equal. Total revenue here is going to be these guys right here. Here's our total revenue for our small team, right? Marginal revenue times their number of wins. Here's our total revenue for our large team. Total revenue here is not equal. We've got, in essence, revenue imbalance. Our large team has a whole lot more revenue than our small team. And because of that, we also have this competitive imbalance, right? Where the optimal amount of wins is not equal to 500. It's something greater than 500 for our large team. We can also think of those areas there, because since that what we're doing is in essence buying talent to get to those W stars, we can also think of those black boxes as being payroll. So our small team is spending this black box here in terms of payroll. Our large team is spending this larger guy here in payroll. So we see here that our owners are paying the same price for talent. Right? They're paying MR star. They're paying the same price for a unit of talent. However it is that you want to calculate a unit of talent. But winning is more valuable to our large team than our small team. And since winning is more valuable to our large team than our small team, they're going to buy more of this talent. Right? They buy the talent enough to get to this guy right here, this large black box, which gives them this revenue of this guy. Like I said, just think of it as you've got 18 players sitting there, and before the start of every single game, everyone sits there and bids on who they want to be on their team for that day. You do that times 162 games. That's in essence what's happening. And to a degree, that's what's happening in the real world over a long stretch of period. It's just that that selection period is drawn out from year to year. It doesn't happen before every single game. But if you think of it as every single game, you can conceptualize exactly what's happening. It's just like the schoolyard. Now this has all kinds of different implications. Because remember, there was some hypothesis that we said was really, really important in sports, and what was that, guys?
Unforeseen outcome.
The uncertain outcome. And what does this say?
Can't predict the outcome.
The outcome is not uncertain. It's not a matter of, well, half the time this team's going to win and half the team's going to win. That's not what it says at all. It says, on more times than not, large team is going to win than small team. You have more certain outcome. All right? And what happens if, for example, our large team gets, say, an increase in the population? So here's our population for our large team, and all of a sudden we have this large increase. What happens if we get something that kind of goes like this? Let's call this MRL, well, let's call it in green, right? They have some, say, increase in population. What happens now?
So now they have an even higher winning percentage after the equilibrium.
That, we've got this holding point here. I'm gonna call this W star. All right? MRS star. MRL star. The winning percentage has changed even more. Let's just do some population Detroit metro area. Population Dallas. So you see here, I don't have the slides to do, I just picked 2 cities. Because they're gonna be different. Doesn't matter who's doing what, you know that they're gonna be different, they're not gonna be the same. So we've got 2 different cities here. We see here that the Detroit metro area population is 4.3 million. Dallas is, say, $7.2 million. But it's not just that, right? I mean, it can also be there's changes in population, right? So if we say, so here's today, let's do this in, say, the year 2000. Metro area 4.4. So here's 2016. Here's the year 2000. Call that 5.16. So we're saying, oh, let's see how things have changed from year to year, right? So we've got our 4.4, and our new value is what? 4.3? 4.3 minus 4.4 is equal to that, divided by 4.4 is equal to that times 100. So our population in Detroit is going down 2.7% from 2000 to today. Dallas has gone from 5.6 5.16 to 7.2. So we got 7.2 minus 5.16 divided by 5.16 times 100. It's gone up 39%. If people, and people don't obviously have to live next to the town that they live in to be fans of that, right? But for the most part, is that true? For the most part, that's true, right? So statistically speaking, what's happening to the number of Detroit fans? It's going down. Statistically speaking, assuming that people have the same amount of like and dislike for sports, regardless of where they move, what's happening to the number of fans for Dallas? Rangers, Cowboys, whatever. It could be anything, right? It's going up. Which means, on average, we should be seeing the Texas Rangers beating the Detroit Tigers more and more and more, right? The optimal level of winning between those two teams is moving more towards Dallas, less towards Detroit. So if these are our only two teams, in the year 2000, Dallas should have won, I'm making up a number, 55-3, right? Detroit would be 46 something. And today it should be Dallas point, I don't know, 592, right? And Detroit's .608, something like that, right? Interestingly enough, when we're seeing these changes here too, not only is the optimal amount of winning changing, but other things are changing as well. You're also seeing the price of talent go up. The price of talent is changing from this MRS black to this MRS green. Right? Why is the price of talent going up? Go back to W star black with this new change for our large market team, MRL green. Let's assume they stay at that level, W star black. What's happening?
Nothing.
It's true about the level of win.
Too much.
Yeah. The value of the next win for the large market team has now gone up. It's now this, I'll call it MRL 3.
Which means that they'd be more willing to pay for more talent.
Exactly. That's exactly what it means. So here's all 18 players all lined up. Now we're gained 48. Let's go back and rebid for talent. Hey, we want to win another game. We're willing to pay that much for the next level of talent. If we can divide people up into little bitty units of talent, which to a degree we can. That's what all the stats are for, right? That's why they keep all those stats. They're not keeping that for fun. They're saying this is how much this guy can do. When I put this guy in, I can predict here's how many hits they're going to get. When I put this guy in, I can predict how many touchdowns you're gonna go. When I put this guy in, I can predict how many rebounds you're gonna get. You're buying talent, and the price of talent has gone up. A win for the large team is now more valuable than it is for the small team. I'm gonna pay up to MRL3 for that next unit of talent. And because I'm buying that talent away from the small team, I'm going to win. Right? And so we see the level of winning increase here to say, like I said, W star green. And so when we see these changes in these guys, we see the price of talent changing, right? The price of talent has become more valuable to the large team. The small team has to also buy talent at that price. The price has just gone up. We see here that the amount of payroll spending has gone up. Right? It used to be this guy here in black, now it's this guy here in green. Same thing over here. The amount of spending from the small team has gone up. We see the revenue from these guys in green has gone up. And then we also see, like I said, this competitive balance increases, it gets worse. The small team loses even more. It's clear in college football that this is occurring. Alabama versus Missouri State. Who's going to win that game? Alabama. They play the game 100 times. How many times is Missouri State going to beat them? I mean, I don't know. Right? Missouri State versus Murray State. That's more equal, right? I mean, this is what you are seeing this in college football. Small schools, relatively speaking, football-ish wise, not small in size, small in market. Large schools, right? Revenue's increasing. How much am I going to pay for talent, right? What am I going to do to recruit people, right? That's the price that you're paying. We don't actually pay the football players, quote unquote, but we do pay to recruit the talent, right? There's the things that we have to do to make them want to come to Missouri State versus Alabama. What do they have to do? Got these types of weight rooms, here's the scholarship, here's the types of facilities that you have, etc. Right? Did you guys see that the University of Texas recently spent $100,000 on each locker? Not $100,000 on the locker room, $100,000 on each locker for each player. So that they walk in, they've got this giant screen, it's got their name on it, it's got all this fancy gear in it. So here's $100,000 for the locker for Missouri State. What do the lockers look like at Missouri State? Just normal lockers? Just normal lockers. So here's what we're going to spend at Missouri State. Here's a locker and a scholarship, free education. Good, sounds good. Texas, free education, sounds good. And a really neat locker. Choose this one, right? It's this price that you're paying for talent. It's this guy right there. And what do we see happening from that? Missouri State, University of Texas, keeps going this way. Right? And what happens as college football grows and more and more popularity? And people want to see more and more and more. The state of Texas is huge. Right? Missouri's not. Missouri's got like 5-6 million people. Texas has significantly more than that, right? The Dallas metro area has more people than the state of Missouri. They're going to have a larger market. Winning's moving this way, this way, this way, this way, this way. So we see these payroll imbalances, we see this competitive imbalance, we see this uncertainty of outcome hypothesis. Right? And in fact, the reason what we dealt with that in college football is we started dividing things up into different divisions. Right? Where you've got basically your Division 1, you got kind of like Division 1A, your Division 2, your Division 3. Kind of started dividing things up by divisions so that we don't have Missouri State University playing Truman State University. Going to be Truman State every single time. Truman State versus Alabama. Alabama's going to be Truman State all the time. They will always win. Right? Started dividing these things up. So what we want to know is we want to know, well, how do we measure how competitively imbalanced things are? Or how much revenue imbalance there is? Or how much payroll imbalance there is? Right? How are we going to measure this amount of imbalance? And we can see the imbalance when we go back to our, I wish this had, okay, small. Oh, it's small one. I'll do that. Don't care. Don't want clean water. Don't care about it. Right, here's our Padres at 83 million. Our Yankees 122 million. Yes, clean water, very valuable. Our that's not what I wanted. Yes, I got it. Please go to. $75 million, right? Or anybody. I mean, any team that you want to look at, you'll get any of them. Right? You're going to see these large disparities in payroll. And we're going to see these large disparities in revenue. What we will see on Wednesday is how we calculate how much disparity there actually is. Because there's nothing